This is the final chapter for our holiday homework. So, this is exercise 5G. So, now we're going to connect these fractions with these decimals that we've just learned. So, let's just go do these do now questions first. 8.4 divided by 2. So, we're just going to set it up like normal. 2 going into 8 4 times, bring the decimal point up exactly, and then 2 goes into 4 exactly twice. Our answer is 4.2. Now we have this kind of scenario where we're going to need to change some stuff. So make sure your divisor is a whole number. So we move the decimal place 3 times. That means we also need to move the decimal place for 9.63 times, okay? So this ends up becoming 9,600 divided by 4. And now we can set it up. 4 goes into 9 twice with 1 remainder. 4 goes into 16 exactly 4 times. And 4 goes into 0 0 times. Final answer is 2400. Now we got here dividing by zeros. So 675. The decimal point gets moved twice. 1, 2. Final answer is 6.75. Alright. Today the goal is to convert between fractions and decimals. Hopefully by the end of the day you can convert decimals into fractions and vice versa. And you can also recognize and write recurring decimals using the correct notation. So, first of all, converting decimals to fractions. So, step 1, look at place value. So, just remember the place values were tenths, hundreds, thousands, etc. If you're confused about that, refer back to exercise 5A. And then step 2, write the decimal as a fraction. And then step 3, simplify if possible. Now, to help you with that, you're going to have a look here. So you start off with the decimal 0.4. As you can see here, the place value in that decimal is a tenth. So in the fraction, you're going to have a denominator of 10 instead. And then once you write the fraction 4 over 10, the reason why there's a 4 in the numerator is because there's a 4 in the question, okay? So you just simplify this fraction here. Next, you got 0.25. So this is the hundreds. So you got 2 decimal places. And the maximum is the hundreds. So in the denominator, it'll be 100, and you put 25 in the numerator. Simplify this fraction here, you end up with 1/4. Next, you got 0.375. As you can see, it's in the thousands. So your denominator is 1000, and then you just simplify accordingly. So let's just go through this. 0.63. This is the hundreds. So now this just becomes 63 over 100. And then you just ask yourself whether you can simplify. So you can't, so you just leave it as it is. This is where it sort of gets a bit weird. So this is also the hundreds. But you'll notice that you have holes. So you have 10 holes here. So this actually becomes 10. And then this hundreds part, it becomes 35 over 100, like so. And next you want to simplify this fraction here. So it becomes 10, 35 over 100 ends up being 7 over 20. And that's it. I'll give you some time to work this out. Right, now we're going to do the opposite, converting fractions to decimals when the denominator is 10, 100, or 1000. So just use your knowledge of place values here. So you got tens, hundreds, thousands. You can just go accordingly like that, okay? Just refer to 5a. So now what happens when the denominator is not a 10, 100 or 1000? So you can do one of two things. Create an equivalent fraction with a denominator of any of these. Or you just do short division. Now, this is where sort of the thing starts happening. Okay. So recurring decimals, they are decimals with repeated patterns. So to represent it, you can do it. You can put a little dot on the top, or you can do a bar. Okay. So these are just some of the examples here. You have 1/3. When you write it as a decimal, it's 0.3, but the threes keep repeating itself. So what you end up doing is you go 0.3 and you put the dot on top, and that indicates that this here is a recurring. Another example is when here 13 over 11, you end up getting 1.1818. So as you can see here, the 1 and the 8s keep repeating themselves. So what you can do is you put the dots on both of them. So this just indicates the start, and this indicates the end of the repeating cycle. But ideally, if it's just one number, put the dot on top. So if it's one number repeating, you put the dot. If it's more than one, you put the bar. Okay. Now convert this to a decimal. So I can pick and choose whatever I like. So there are some examples where making an equivalent fraction is better, and there are some examples where doing short division is a lot better. In this case, I got lucky, so just focus on that 3 over 5 there. So 3 over 5 can be written as a denominator of 10 times 2 times 2. So I end up with 6 over 10. And now, since it's 6 over 10, can be written in a decimal form as 0.6. But because we have 5 wholes, we end up getting 5.6 as our answer. In this next one, I can't really convert the 12 to a denominator of 100. So what I'm going to do here is I'm just going to do this simple sort division. Now, remember, when it comes to these decimals, when I add the zeros, they don't change the value. So I can add zeros if I'd like to. So how many 12s go into 7? Oh, it's 0 times. Bring the decimal point up. Like so. This now becomes the number 70. 12 goes into 75 times with 10 remainder. This now reads as 100. 12 goes into 100 8 times with 4 remainders. 12 goes into 43 times with 4 remainders. 12 goes into 43 times with 4 remainders. And then same thing. And you sort of start noticing, oh, hey, there's a pattern here. So you start noticing it keeps repeating. So this is an example of a recurring decimal. Now, because there's just one number repeating itself, I can just put the dot above the 3. I'll give you some time to try it out. Give it a go. Right. These are the solutions that I have made for these. Just make sure it matches up with your own. And these are the questions that you got to do. Take care. Enjoy your holidays.